We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Hello dear students, today in this lecture we are going to study about one of the very interesting law of physics that is known as Ohm's law. In this particular article we are going to study about its statement and how to prove this Ohm's law. The detailed explanation will be carried out in this particular lecture. So first of all, we will start with some example, that is, why do we not experience a fatal shock on touching a 6-volt supply while on touching a 230-volt source? One experience is a fatal shock. So you can say due to the higher amount of voltage, but here by ending up this article you will have a clear idea that why this voltage supply means a lot for this fatal shock experience. In these examples, for different voltages, the electric current flowing through the body is different. Why? Because there has been a different amount of resistance are experiencing, because our body has a definite value of resistance, and if you are still increasing some amount of voltage, then it will surely affect when it will overcome the limited resistance value of your body. In 1828, a German physicist, George Simon Ohm, was the first person to give a mathematical relationship between the voltage and current. See, this voltage and current are two different phenomena. The current is the flow of electric charge, okay, and the voltage is the source of electric current. So these two are the different parameters and different physical quantities as well. Ohm experimentally proved that, so this is now what we call the statement of Ohm's law. Under a definite physical condition, here we have to maintain the constant temperature, okay, which is the definite physical condition. The current, which is symbolically represented as capital I, flowing through the conductor is directly proportional to the potential difference, that is the capital V, applied across its ends. So when you consider any kind of conductor material from which the electric current is passing, so we know that the conductor is connected to the two ends, that is the positive and negative terminal. So whatever the potential leakage or potential difference between this positive and negative ends will be termed as your voltage, and whatever the amount of electric charge passing throughout the conducting material at different atomic points, so that is known as your electric current. So this is the statement called Ohm's law, and according to Ohm's law, from this statement we can mathematically give an expression like I proportional to V. That means we can say V upon I is the constant. So now it's our duty to identify what will be the constant. So here from this first line we can experience the constant value is nothing but your resistance, okay. So you may have noticed that, suppose you have applied 5 volt potential difference to the conducting material, but this is your input voltage, you will not surely able to find out your output voltage as 5 volt. It will be always less than the input voltage. So what are the parameters affecting the conducting material or any material or any circuit with which the input and output voltage differences have been observed. So the major factor which affect in this particular phenomenon is nothing but the resistance of the conductor in present case, because here we have used the conducting material. So this constant ratio V upon I is called the resistance, symbolically represented as capital R, and hence by substituting this constant value in this equation we have V upon I is equal to R, or you can simply identify it as V is equal to IR. So this is the final mathematical expression of Ohm's law and proof of the Ohm's law theory. Now it is again our duty to determine the unit or dimensions of this particular constant. So what will be the constant of this resistance? Because we know that the potential difference capital V is measured in volt, as you have seen here. The electric current capital I is measured in ampere. So the ratio of volt upon ampere will be the dimension or unit of this resistance capital R. So how to identify the dimension? So it is denoted by omega symbol and it is pronounced as ohm. Okay, so the unit of resistance is ohm and symbolically represented as omega. So this was all about the Ohm's law theory, in which we have now introduced with the new quantity, physical quantity, that is the resistance, which predefinedly exists inside any material. Okay, so I hope that this particular topic is now clear in your mind and it will be helpful for your GTU examination in 3 to 4 marks question. So thank you for visiting this lecture.